Yes. Yeah. Yeah. Good evening, all. Right. So we had a session right previously. Right. I was just briefing you about what is big data, why Hadoop and Spark, drawbacks with the current databases, advantage of Hadoop and Spark, right? The Hadoop and Spark job market and PySpark. So here Hadoop is meant for two things. Hadoop is meant for both storage and for processing. Hadoop is meant for storing as well as processing. Any technology performs storage or processing, but Hadoop performs both storage and processing. For storage, does it use any database? No, databases has got some drawbacks. Despite of those drawbacks, still Hadoop doesn't go with databases. It is going with a kind of file system called Hadoop distributed file system. For processing, MapReduce or Spark. Hadoop is meant for batch applications. Hadoop is not for online applications. Online applications means user interactive application. User gives the input, but in batch applications, user doesn't give any input. User non-interactive applications. Credit card statements for millions of customers. Example, right? Generating credit card statements for millions of customers here, user input is nowhere required. But if it booking a movie ticket, user input is required. Making an online transaction, user input is required, right? I was talking about in the previously, I was talking about drawbacks with the current databases. Most of the databases are limited storage, no parallel processing. If volume increases, speed decreases. The volume of the data is increasing. Total amount from sales one, total amount from sales two, total amount from sales three. 10 records, 10 lakh records, 10 crore records. Record to record, right? If the volume increasing, if the volume is increasing, speed decreasing, right? Yes. Even if complexity increases, the speed decreases, right? Even if complexity increases, speed decreases. Total amount, the average amount, standard deviation of amount. Here, average amount takes more time, right? As compared with the sum. First, sum to be calculated, next average has to be computed. As compared to this, average amount takes more time. Standard deviation of amount. Standard deviation of amount, right? Lot of internal processing is required. Lot of internal processing is required. Databases can handle only structured data. They cannot handle unstructured or semi-structured data. So these are the major drawbacks, right? With the databases. We've come to this Hadoop advantages, right? Hadoop advantages. Unlimited data storage. Unlimited data can be stored. Unlimited data storage. Horizontally unlimited number of unlimited slaves. Very high speed processing because of parallel processing. Can handle all varieties of data, structured, unstructured, and semi-structured. It's open source. No licensing is required. Commodity hardware. Can run on all the hardwares. Doesn't mean that it should have highly configured, right? It can run on any heavy hardware configuration. Why databases like Oracle cannot support unlimited storage? Even databases can go with multiple systems or multiple slaves. Talk about these databases and max limit on the number of slaves. Oracle can go with a maximum 256 nodes for storing its data. MySQL with 54. MySQL Express with 256. SQL Server 256. DB to 256. Teradata can go with a maximum 512 nodes. Teradata, Netija, and Vertica, they're used for data warehouse, right? Specialized databases used for data warehouse purpose. So all these three 512 nodes. But these two, Teradata and Netija, currently they are going with 1024 nodes for storing its data. So here, but there is no limit on the number of slaves that Hadoop can have, right? Yahoo, when first time implemented Hadoop, went with 4,000 nodes for storing its data. Currently, Yahoo going with 12,000 nodes for storing its data. Systems, nodes means systems. Facebook, when first time implemented Hadoop, Facebook, when first time implemented Hadoop, went with 8,000 nodes for storing its data. Currently, Facebook going with 52,000 nodes for storing its data. So if you see the speed, if you see the speeding, this is what Hadoop is prevent storage point of view and even processing point of view. If we talk, it has taken a table. Yahoo has taken a table to check the speed of different databases. Has taken a table of 100 TB consisting of 1024 columns. Task sorting based on 16 columns. Time taken, right? Oracle has taken nearly 3.5 days to process. MySQL, right? It has taken nearly 6 days. Teradata, like 4.5 hours. Netija, 3 hours. Hadoop, 3.4 minutes. Latest version of Hadoop has just taken 1.2 minutes. Okay, so these have taken days of time. These have taken hours of time, but Hadoop has taken minutes. But even Hadoop has got very high speed, right? Hadoop has got very high speed. But Spark is 100 times faster than Hadoop. Spark is 100 times faster than Hadoop. See the speed of Spark. Already Hadoop has got very high speed where it has taken only minutes of time. But Spark is 100 times faster. Okay. So very high speed processing, right? Both Hadoop and Spark commonly used together, right? Yes. So now, how exactly data stored? See how exactly. See, before that, I was discussing about architecture, right? Yes, if you observe, Hadoop was just talking about this. Hadoop doesn't follow client server. Hadoop doesn't follow client server architecture. It doesn't follow client server architecture. Hadoop follows a master slave architecture. It follows master slave architecture. It follows master slave, single master, multiple slaves architecture. Hadoop cluster means group of nodes means systems connected in a network. Hadoop cluster means group of nodes, systems connected in a network. There are two types of nodes: master node, slave node. There are two types of nodes: master node and slave node. Master node we call it as a name node. Slave node in Hadoop terminology like a data node. Master node responsibilities, yes, task assignment, load balancing, assigning tasks to the slave systems. The task should be equally given to all the slaves. If the fault tolerance means if any systems fails, multiple tasks are executed by multiple systems parallelly. If any one slave, if any one slave fails, then the task of it has to be assigned to any of the other slaves. Health monitoring. Health monitoring, right? Yes. Okay. Slave node responsibilities, storing the data and processing the data. Slave node, okay, just observe this diagram once. Hadoop follows master and slave architecture, single master and multiple slaves. S1, S2, S3 up to Sn. So this is master, these are slaves. Master node. This is slave node. Slave nodes we call it as data nodes. Means data stored within the slaves, data processed by the slaves. Means if we talk about any file f1.txt, this we call it as a cluster. Group of systems connected in a network. Group of systems connected in a network. Two types of nodes: master node, slave node. Group of nodes connected in a network. One is master, remaining all are slaves or data nodes. So f1.txt. You have got a file f1.txt. We have got f1.txt. The file, for example, each system capacity 1 TB, 1 TB, 1 TB, 1 TB. This file size is 2 TB. It cannot fit into any of the slave systems. It has to be divided into smaller parts and has to be distributed across multiple systems. The advantage we see is distributed. Data is distributed across multiple systems and data is processed by multiple systems. Data stored across multiple systems. Data processed by multiple systems parallelly. Data stored across multiple systems and data processed by multiple systems parallelly. Distributed storage and parallel processing. Right. How exactly the data stored and processed, right? How exactly the data stored and processed in Hadoop. In Hadoop, data is stored in the form of files. In Hadoop, data is stored in the form of files. Each file is again subdivided into subdivided. File is again subdivided into blocks. File is again subdivided into blocks. Blocks are distributed. Multiple slave nodes and are processed. Blocks are distributed across multiple slave nodes and are processed. Default block size. Default block size is 64 MB. Latest versions, it is 128 MB. Default block size 64 MB. In latest versions, it is 128 MB. For example, I got f1.txt. Size is 200 MB. f1.txt size is 200 MB. Assume it is some banking data. It has got some banking data. Default block size. Assume that default block size is 64 MB. Default block size 64 MB. Number of blocks into how many blocks? Number of blocks. File size by default block. File size by default block size. So f1.txt size is 200 MB. It has got banking data, right? Default block size 64 MB. Number of blocks. File size by default block size. File size is what? 200. 200 by 64. 200 by 64 means like approximately, right, 4 blocks. Approximately 4 blocks. B1, B2 means 64, 64, 64. 192 you will get plus 8 MB. Fourth block. Fourth block has got 8 MB. B2, B1, B2, observe here, B3. B4. B1 block, B1 block 64 MB. B1 block has got 64 MB. B1 block 64 MB. B2 block also like 64 MB. B3 block also 64 MB is stored. In B4 also 64 MB. Sorry, in B4 8 MB only. MB only. 64, 64, 64 means 192. 8 MB only in the means 56 MB free here. 56 MB free. I got F2 dot same thing. Same thing I'll copy. There's one more file. Assume you got one more file. F2.txt. Size exactly 192. Assume that you got some telecom data. Default block size 64. Number of blocks 192 by 64. Exactly 3 blocks. So here B5, B6, B7, B5 has got 64 numbers. So these are stored in which system? System right? System 1. This in system 2. This in system 3. B5, B6, B7 also they are storing 64 MB, 64 MB, 64 MB. 64 MB in this, 64 MB in this, 64 MB in this. S4, S5, S6. Here my query is 56 MB free here. If data is not stored in this B4. 56 MB free. F2.txt. 100 MB only. Default block size taken 10 MB. Number of blocks 10 blocks. Is it advantageous? Is it advantageous, right? Already the file is already it is a very small file. A very small file. And again dividing into smaller parts. Again dividing into smaller parts. Distributing across multiple systems. Processing. And later combining the result. And later combining the result. And later combining the result. Is a time taking process. So the block size should not be too big or too small. So the block size should not be too big or too small. That's the reason Hadoop has given default block size. (128 MB). Still, okay, depending some as you said, right? Even depending upon the data also, you can increase or decrease. Depending upon your cluster capacity, depending upon the incoming data, you can also decrease or increase, right? Based on that, what speed you are expecting, right? So you cannot have too much big or too much small. Okay, understood, right? Yes. This is what default block size. We can also configure, I'm saying. Yes. Now I'm going to discuss 4 cases, right?
So just a small doubt here. If the file size is less than the block size means, then how that scenario means?
Now I'm just going to say this.
See that, okay. Because based on that conversation, I got doubt, so that's why I asked. Thank you, sir.
So here I'm going to discuss 3 cases in that 3 cases in that case one. Case one is number of blocks equal to number of slaves. What was that? What was that you asked? If the block size?
No, the block size is default 128 MB, right?
Mm.
So the file have block size means how it divided into the blocks like that. Like it did go to the first block only, or again it will also
Only
divide
one,
in
only one block. If
one
it
block. Yeah.
has got 64 MB, if it has got 8 MB, the 8 MB will be storing, but remaining will be free.
Okay. Yeah, that only so. Sure.
If number of blocks equal to number of slaves, number of slaves. For example, think that you got 4 blocks. You got 4 slave systems. Number of blocks means B1, B2, B3, B4, B4. You got 4 blocks. Slaves like S1, S2, S3, S4. How exactly the data storage and processed you can see here. How exactly the data stored and processed in Hadoop.
Sir, and I have a small doubt here. Sir, each block, while transferring the data, it's fully loaded or something will be kept for storage.
Each block, once again,
If B1 has the 64 MB data, 64 MB storage, sir.
mm,
So 100 MB's data is coming enter into the P1. Is that fully loaded 61 MB or something? Some storage will be
see,
kept like
see,
that.
very simple, right? Okay. You got 10 blocks are there. 10 blocks are there. 64 MB. Assume that your file is divided into 10 blocks,
Okay.
4 MB blocks, f1.txt, f1.txt, right? 10 blocks. You have got how many systems? 5 systems are there.
Yes.
5, 1, 2, 3, 4, 5. Please be in with 5 systems are there. The system 1, system 2, system 3, system 4, system 4, system 5. But 10 blocks are, how these 10 blocks are going to be stored into this 5 systems? First, B1, B2, B1, B2, B3, B4, B5. Again, B6, B7, B8, B9, B10. Means each system storing 2 blocks. Each system will have equal value. Only that B10 will have the less value. Anytime you see whatever the file size, only the last block will have that less size. B1, B2, B3, B4, B5. But if you got only 2 systems, S1 and S2, in S1 5 blocks will be stored, in S2 5 blocks will be stored. Means all will have equal volume except the last one will have less value. So depends upon the number of systems, the blocks are distributed. Means whatever might be your file size, with whatever your work is what, just specifying the block size. Automatically, rest it is going to take care by itself. Means it is going to divide into blocks, and the blocks it is going to distribute across multiple systems. But everything taken care by the Hadoop framework itself. So whatever the size it is, divides into blocks and stored across it. Because you'll be storing you'll be maintaining a cluster with multiple systems, so they'll be distributed across. But okay, the difference in the speed you will be observing, that what I'm going to discuss in the next going to discuss 3 cases now. If the number of blocks equal to number of slaves, very high speed you see, very high speed. For example, f1.txt size 230 MB. Assume default block size is 64 MB. Executing, T3 will be in waiting state here. When T2 is executing, T4 will be in the waiting state. Means only 2 tasks are executed parallelly. Remaining 2 are in the waiting. Think that 40 tasks, 20 slaves only are there. These 20 slaves can execute 20 tasks parallelly. Remaining 20 will be in the waiting state. Means once these 20 tasks got completed, the next 20 tasks will execute. Here also, once T1, T2 complete execution finished, next will execute T3, T2. Means some tasks are in the waitings. That's why I'm saying lesser speed. In the case 3, if you observe this case 3, right? In the case of case 3, more blocks, only one slave. More blocks, only one slave. More blocks means 4 blocks. Only one slave. S1. B1, B2, B3, B4. Only one slave S1. B1, B2, B3, B4, only one slave. 4 blocks, only one slave. Means one master, one slave. S1. Here only all the slaves B1, B2, B3, B4. This master node, name node stores the metadata f1.txt into 4. B1, B2, B3, B4. B1 by S1 only, B2 also by S1, B3 also by S1, B4 also S1. Even if you talk about this data processing, job to process f1.txt divided into tasks. The task, nothing but number of unique blocks. How many blocks? 4. 4 blocks means 4 tasks. 4 tasks means T1, T2, T3, T4. These 4 tasks should be executed by S1 only, S1 only, S1 only, S1 only, sequentially, one after the other. No parallel processing here. 4 tasks executed by 4. Means this 4 tasks should be executed by S1 only, sequentially, one after the other. No parallel processing. No parallel processing means here, if more slaves, more speed. Less slaves, less speed. Only one slave, no parallel processing. Just like if you got a laborers for a building construction, more laborers, building construction will be fast. Less labor, it will be slow. If only one labor, right, it takes a lot of time. In the same way here. But I got a query here. If you go back to this case 1, if you take case 1, right, here T1 task assigned to S1, T2 to S2, T3 to S3, T4 to S4, because 4 blocks, 4 slaves, 4 tasks assigned to 4 slaves. Okay, this T1, T2, T3, T4 are executed by 4 slaves, S1, S2, S3, S4. Suddenly, if any one system is down, as these are machines, 4 tasks executed by 4 systems parallelly. Suddenly, if any one system goes down, then Suddenly, if any one system goes down, then 10 lakh records are lost. You can see two drawbacks here. 10 lakh records are lost, and this T2 task is failed. T2 task is failed, then job will be failed. Yes, T2 task is failed, job will be failed. Means 10 lakh records, if it is sensitive data like banking data, 10 lakh records lost means it's a huge loss. But if it's insensitive data like Facebook data, it's not, right? So how Hadoop is going to overcome this kind of issue means there's a concept called a replication and a fault tolerance. Fault tolerance. Replication and fault tolerance. Replication means duplication. Duplicate, if the data is too sensitive, then we will be duplicating the blocks. B1, B2, B3, default replications 3. 3 times you will be duplicating. Even if any one slave is down, still you have got the duplications, right? Still there won't be any data loss. Even there won't be any task failure, right? With that replication and fault tolerance. Fault tolerance means if any one system is down, then the task of it will be assigned to any of the other system. That is what fault tolerance. Okay, fine. So this replication and fault tolerance, we have got a discussion on it. We'll be discussing it, right? Understood how exactly the data stored and processed in Hadoop, how it is divided into blocks and how the blocks stored across multiple systems, what is the default block size, how to configure the block size, and yes. Next, in the next session, I'll be discussing this fault tolerance and replication and Hadoop storage architecture and processing architecture. Hadoop storage architecture and processing architecture, and I'll be discussing about the software. The software I'll be providing to your Google Drive. You can download from there, and you can I'll be demonstrating about it in the next week, right? Fine. So yes, so my total concentration will be on this PySpark, right? Spark with Python, Spark with Python, right? Yes. So as I said, PySpark, Spark with Python implementation. So when I am discussing Hadoop, people, if it doesn't have knowledge on this Python, you'll be updating with Python parallelly. Hadoop and Python, both will be, this will be from Monday to Friday. Any of my batch, right? Python batch. So 9 p.m. batch is there for Python, Monday to Friday. 6 a.m. batch also there. If anybody wants morning, you can go with 6 a.m. Evening means 9 p.m. you can check for Python, total Python core and advanced, right? Total core and advanced, because total coding goes in Python. You need to have that command of this Python language. Python will be discussed. Linux, Python, Linux, PySpark, and Hadoop. So initially for Hadoop, there doesn't require any Python knowledge, but when we enter into PySpark, you require Python. Okay, fine. So yes, check with this, right? Check this course content of this Hadoop